So today we are going to start this chapter on factorization. Now this chapter factorization, in this chapter you will learn two theorems. Okay, this chapter basically consists of two theorems. First theorem here is remainder theorem. And the other is factor theorem. Okay, we are going to learn these two theorems in this chapter. This chapter, there is nothing else in this chapter. We'll start with remainder theorem. Okay, but before remainder theorem, just a small reminder of your elementary concept that you had done in back in class 8 also. So we'll just start with some of the elementary concept before coming to remainder theorem, and then we'll move on to your factor theorem. Okay, so let us start with the elementary concepts here. The first concept is that of a linear polynomial. Okay, I'll send you these notes today. Now, any algebraic expression of the form ax plus b is a linear polynomial. Okay. Now, why is this linear? Because you see that the power of here is highest power of x here is 1. Okay, that is why it is called a linear polynomial. The highest power of x here is 1. Next, you have a quadratic polynomial. This is different from quadratic equation. Polynomial means only the left hand side of the equation that you are writing, only the left hand side of the equation. That expression is called polynomial, quadratic polynomial. This ax square plus bx plus c equal to 0. Not equal to 0. This only this expression, the left hand side, okay, of the equation that we just did. This is called a quadratic polynomial. Okay. Why is it called a quadratic polynomial? Because the highest power of x here is 2. That is why it is called a quadratic polynomial. Okay. Now, how do we get a quadratic equation? If we equate a quadratic polynomial to 0, we get a quadratic equation. If we equate quadratic polynomial to 0, we get a quadratic equation. Similarly, if you equate a linear polynomial to 0, you get a linear equation. You get a quadratic equation. Say x square plus bx plus c. This is a quadratic polynomial. You equate it to 0, you get a quadratic equation. Okay. So that is what. So remember, the left hand side of the equation only, the algebraic expression on the left hand side of the quadratic equation is called quadratic polynomial. Next is cubic polynomial. This expression, algebraic expression, where the highest power of x is 3, is called a cubic polynomial. Okay, and finally you have biquadratic polynomial. This is called a biquadratic polynomial, where the highest power of x is 4. Okay, now you'll say what is the highest power of when the highest power of x is 5? What do we call it? We call it for powers of 5 and higher. We simply call it polynomial of degree 5 polynomial of degree 6, polynomial of degree 7, and so on. Okay, so these are all your degrees. This 1 is called the degree of the polynomial. This 2 here is called the degree of the quadratic polynomial. So what is the degree of the linear polynomial? The degree of the linear polynomial is 1. The degree of a quadratic polynomial is 2. The degree of a cubic polynomial is 3. The degree of a biquadratic polynomial is 4. And for power 5, you simply call it polynomial of degree 5. For power 6, you call it polynomial of degree 6, and so on. Okay. So this is what the 4 types of polynomials we have discussed: linear, quadratic, cubic, and biquadratic. Okay. Now a polynomial is normally denoted by fx or gx. Okay. So polynomial is denoted, if I want to write uh, right, fx is equal to 2x square minus 5x plus 2. We write it this way. Okay. Fx is equal to this. Or we write gx is equal to 2x cube plus x square plus 3x plus 1. Okay, this is the way of denoting polynomial. Just as we write any x, we normally we say x is equal to 2. So polynomials we call it fx, gx, hx also we use sometimes. Okay, so that is what polynomials are denoted by. Now, what do you mean by the value of this polynomial? Suppose I give you this polynomial. Suppose if I give you suppose fx is 2x cube plus x square plus 3x plus 1. This is a polynomial. What type of polynomial is it? Anyone? What type of polynomial is it?
Sir, cubic.
Cubic polynomial. This is because the highest power of x is 3. Okay. So if I give you this polynomial and I say find the value of fx at x is equal to minus 1. Okay. So this polynomial will have, if I put x is equal to minus 1, this polynomial will have a certain value. What is that value? So we'll write, therefore, value of fx at x is equal to minus 1 is f minus 1. Okay, remember this notation. Value of a polynomial at x is equal to minus 1 is f minus 1. Or value of a polynomial, if instead of minus 1, if it was given to you as 5, then it would be f5. If it was given to you as minus 3, it would be f minus 3, and so on. So since here it is given to be minus 1, so the value of fx at x is equal to minus 1 is f minus 1. And how do we get the value? You simply put it here in the polynomial. Twice minus 1 cube plus, instead of x you are putting x is equal to minus 1. This is minus 1 square plus thrice minus 1 and plus 1. You simplify this to get minus 4. So what is the value of fx at x is equal to minus 1? It is f minus 1, which is equal to minus 4. Okay. Similarly, if I want to find out the value of the same polynomial at x is equal to, say, minus half. Therefore, value of fx at x is equal to minus half is f minus half, right? Now put the value in the polynomial. What is the polynomial? Twice x cube, so twice minus half cube, plus x square, so minus half square, plus 3 minus half, plus 1. Okay. So now you can simplify this to simply get this as minus half. Okay. So value of the polynomial fx at x is equal to half is -1. Right. Degree of the polynomial is the next concept which I've already discussed. Okay, if a given polynomial is there, the highest power of x is called the degree of the polynomial. That you already know. Okay, but we just let me write the notation for it. Degree. Suppose if I give you this polynomial, that fx is equal to 3x square plus x minus 1. What is the degree of this polynomial? We know the degree of this polynomial is 2. Therefore, we write degree fx is equal to 2. Okay. Similarly, if I have a polynomial x cube plus 1, then what is the degree of this polynomial? Degree of gx. Highest power of x here is 3. Degree of gx is 3. Okay. That's it. Now we come to the main part, which is called the remainder theorem. Having discussed these elementary portions, we discuss the remainder theorem. Okay. But remainder theorem will be discussed in comparison to the division of polynomial that we have done earlier in class 8, if you remember. Suppose if I give you this question that I have discussed here, say find the remainder when, say I call it fx is equal to 2x cube minus 7x square plus 3 is divided by x minus 2. Okay, you have done this in your class 8 to divide two polynomials and to get the remainder and the quotient, isn't it? So what you do is you divide according to our method, 2x cube minus 7x square plus 3. So first of all, we must multiply x. We see that the power of x here is 3 and the power of x here is 1. So we must multiply x minus 2 by x square, right, to get the power 3. But we also have a 2 here. We multiply by 2x square. So to get 2x cube minus 4x square. So what you do here is, since you have multiplied x minus 2 by x 2x square, you write 2x square above. And after multiplication, how much are we getting here? We are getting 2x cube minus 4x square. And next, what was your step? You subtracted, right? Cancel this. Minus 7 plus 4 will give you a minus 3 x square plus 3. Right? Now you see here that you have x here and you have x square here. So this has to be multiplied by x to get an x square. But you also have a minus 3. That means there should be a minus 3 also here. That means you have to multiply x minus 2 by minus 3x. So you will get minus 3x square plus 6x. Okay. So what you do here is, since you are multiplying by minus 3x, you write minus 3x on top. And you're getting minus 3x square plus 6x. Subtract, cancels. Now what do you get? You get minus 6x plus 3. See that here again, you have the power of x here is 1, the power of x here is 1, and the power of x here is also 1. But you additionally have a minus 6 here. So you multiply this by minus 6, right? So minus 6 into this entire one, x minus 2 will give you minus 6x plus 12, right? So now, once you have multiplied, what have you multiplied by? You have multiplied by minus 6. So you write minus 6 on top. You get minus 6 plus 12. And then you subtract. Cancels, you get minus 9. What did we say in class 8? If you remember, we call this as the quotient, right? Therefore, quotient is equal to 2x square minus 3x minus 6. And what was the remainder? This we called as the remainder. Right? So now my question was, what should be the remainder when this is divided by this? My question was only to find out the remainder. My question was not to find out the quotient. But still I carried out the entire division method so long to find out the remainder as minus 9. But along with it, I'm getting the quotient also, which was not required, right? So since we are not required to find out the quotient, we only required to find out the remainder. Instead of using the division method, we could have directly applied the remainder theorem. And how would we directly apply the remainder theorem? In this, I will explain it to you in the next class. We don't have any time left. What we do here is, see, we are dividing by x minus 2, right? So what you do is you put x minus 2 is equal to 0. That is the rule for remainder theorem. You put whatever divisor that you have, you put that equal to 0. So how much do you get? X is equal to 2. And now this x is equal to 2, you put it here in this. Okay. And whatever value you get, that will be your remainder. Is that clear? I'll stop here for today.